what I'm going to do today is to go through all the different programs in the PowerPad range. And if we look at the Light suite, we can see that we have PowerPad, we have a Student Edition, and then we have the Office tools. Today we're looking at PowerPad, and for people who are coming in as students, this will cover all the facilities in the Student Edition as well. And it tells you what all is in here and what we can do. But one of my colleagues very kindly today generated a lovely little presentation, if it doesn't make you seasick, on what PowerPad is about. So I'm just going to go back to the start and look at the whole suite of PowerPad in a very diagrammatic fashion. So we have 4 versions of PowerPad. We've PowerPad with the Plus, which is the most common version. With the PowerPad 300, and we have the Student Edition. The core behind the PowerPad is the fact that it gives you real programs. So we have the master frame program with either 15, 100 or 300 members, and that allows you to do beams, trusses, portals, grillages, plane and space frames, and we can do those in steel, concrete, timber, and we can also design our connections. In fact, we can do them in all 3 materials at once. So you could have a concrete frame with a little portal or truss sitting on top of it, and some timber in it, and then design the connection. So all integrated in that one system. And if we move forward, we will see then we also give you a version of Masterport. Limited 15 members, but that means you can do 3 span portals. 3 equal spans, 3 unequal spans, north lights, stepped portals. As long as it's a total of 15 members, that's okay. Sorry, wrong click. And that again integrates in through to do your steel design, to do your concrete pad foundations, and to design all your connections in your frame. So that's the 2 principal analysis engines that we utilize in this PowerPad. And then we also have, for those quick little beams, the beam designers. 1 to 3 beams, simply supported, continuous or cantilevers, and they can be in concrete, steel or timber, and that is great for doing those very quick little beams. And then to complement all that, we also have these standalone modules for doing those other types of civil works that you do: masonry panels, pile caps, retaining walls in concrete and masonry, and composite beams. And then finally, what a lot of people think is PowerPad is our Calc Wizard and the Office tools, and these allow us to, or allow you to, create templates of non-typical designs that you use over and over again, especially just for you. And we also in here give you the ability to export all those results into Word and Excel. So I did forget to say that if you have any specific questions during this session, just type them into your little question box, and my colleague Martin will either answer them on the spot, or he will keep them for you, keep them for me to review at the end of this webinar. So there we go. That is what is in PowerPad. And what I would say is that there's nothing in PowerPad that you couldn't buy on its own. So if you only needed to do steel design, it may be economical to just buy a master frame at, say, 100 members plus your steel design. If you only do concrete, well, we can go in and buy master frame and the concrete. If you only do portals, let's look at the portal frame. But for those of you who are in a multi-discipline office or a small office and want to do a bit of steel, bit of concrete, bit of timber, retaining walls, this is your ideal starting system for doing your design. And the nice thing is, and we will see that later when we come back here and review everything afterwards, that the whole system is upgradable. So you can go to bigger frames, you can go to more complex retaining walls by adding in an additional module. So just press escape out of that, and I'll just minimize that and come back to master frame. So into the master series, we're going to actually review the different parts of PowerPad and look at them in detail, but not really in technical detail, just to show you what they all can do. Because if you wanted to actually review what all the master frame can do, that would take an hour on its own. So if you're interested in finding out more details on any of the individual programs, I suggest that we walk back into the master series, go to the product range. Instead of going to the light suite, let's go and look what the master frame can do. So we can see here general frame analysis, and we can then see here what the different features are: tapered members, elastic, plastic, P-delta, torsion, all of that. And that's all included in the PowerPad version. There's nothing in this list that's not in the PowerPad version. Your P-delta is in the PowerPad version. The only limit is your 15, 100 or 300 members that is in the PowerPad system. And then obviously the add-ins that come with that you can add in afterwards. If you want to see what your connections can do in detail, you can go to your steel design and then just come up to connections, and you'll see what the connections are and what all the different facilities are. And obviously there's fantastic little videos on all of these different products for you to view. What we're doing this morning is reviewing just in general what PowerPad's all about. So let's look at my program, MasterSeries 2015.10. Not sure, I think there's a newer version out, but not to worry. It's licensed to myself, and let's have a look at my license. So I am licensed for PowerPad Plus. I don't have any additional licenses other than the PowerPad limits on each of the different programs. So I can see steel design up to this 100 member limit, concrete design up to 100 member limit, beam designers up to 3 spans, portals up to 3 spans. It says fully licensed, but that's not technically correct. It is the 3-span version. So let's just close that and into the first, what people will call the core program, master frame. So I said that we can do a lot of different frames, and if I come in to just general frames, if I have the full version of master frame, I can do all of these huge big industrial type buildings and get very, very powerful. In our PowerPad system, we're taking it back a step, and we can do simple beams. We can do little A-frames in domestic houses and things like that. We can do a little attic conversion frame. Again, very simple. We can do trusses, in this case quite an unusual truss. Some more truss members. Just about pushing the boundary there on the 100 member limit. A nice curved truss, ground beams and grillages, lovely, very straightforward for your ground beams on pile caps. You just put your supports in, and very straightforward. Plain frames, this is a portal with mezzanine floor and trusses, as you can see. We can even create little towers and do things in 3D. Here's a concrete frame we'll be looking at later on. Even in the master frame, we are able to do portal frames. And we will be looking at this frame in detail in a moment. This is a nice 3D frame, and that's some sort of industrial frame. And this is a house with inset storage and obviously car parking, whatever somebody's done in 3D. And this is a nice little escape fire escape that somebody's analysed in the PowerPad arrangement. So I want to go back and I want to look at this little frame. And originally somebody had actually used 3D Model Manager on that. I'm not going to worry about that. It's all been turned off. So let's get into this and look at how powerful the program is. The program gives you all of the editing facilities that you have at MasterFrame. It does not give you the 3D model, obviously. And if I wanted to find a new member, it's dead easy. I can use snapping. So first of all, if I want to put some bracing in, I could come along and say, let's put in a circular hollow section that is coming down here, something like a 114 by 5 mil. And I can then swing around here and put in some bracing between that node and that node. Very simple. And then I could put this opposite coming in there. I can also, while I'm doing that, do advanced things like saying, well, actually, I should release the ends, and it is a tension only member. So if I put it in as tension only, take that back out a second, so you can redraw it to remove it. And this time, if I put them in as being tension only, then that has automatically put those in as tension only. So very simple but powerful generation of your members. And if I show it in 3D, we will see that I've got my trusses, and I've got two different column sizes, which might be a bit of fun to create, and our bracing in here. And you'll see even in the color schemes that they're all different sizes and the likes. So that's putting in members between nodes, but clearly you still also want to put in members between other members. So if I wanted to suddenly create a wee lean-to coming out here. So before I start, let's have a wee quick look at my snap settings. So I'll turn off polar snapping, because that would make things very complicated. And I'll turn off auto tracking. Can be useful sometimes, but sometimes can overpower you with the number of points that actually are available. Object snaps, certainly I'm going to have perpendicular from first member and orthogonal from first end of member. Midpoints, we won't use it at the moment, but it's useful to have it on. And then on the snap grid, we will just have everything to the nearest 100 millimeters. So I want to come along and I want to take from here, I want to come straight out 3.4 meters. But if I want to, I can make that 3.55 meters. So as you can see, that is a projection of from here orthogonally. So I want to just drop down another member, and all the time I could be changing here to different section sizes. So for my column, I could turn around, make that a UC, and make this a wee 203. And from here I will drop down and I'll just hover over and get a intersection then there. And I will just rotate around and do the same out of this. And I'll leave it as a UC just to save me time. And then come down, hover over. I will put that one in first, and then hover down. We just need to rotate possibly. There we go, we got the snap and drawn in. So that was the easy bit, doing the grounded first. Now we want to create some members that come along and continue this slope down. So very simply, I can ask it to snap up and snap down. As I can see, the green line is highlighting, telling me that I am on a projection from that rafter. And while I'm here, I'll just draw that down. Repeat the same on this side. Just rotate that around a wee bit so I'm not getting interfered with the there we go. We are now on the intersection. Pop the member up and member across. And that was very, very quick to do. Obviously our section sizes, as I said, are a wee bit random on the structure. There's no reason why I couldn't have done all the beams first, then the columns, and then the sloping rafters. And just to finish that off, a wee bit of bracing with a couple of angles, equal angle, 70% by 6. And at this point, it's probably easiest if you try to turn off most of the snap points. So that they're only snapping to nodes. That just makes it that bit more accurate. And there, and some more bracing there, and there, but we'll portalize that ground floor. So that's putting in members, and we put them in as steel sections. Very, very straightforward. Putting in loads, well, that's note on and sections. I want to change the section size, for example. I can just come along to a member and see what the section size is, and again change it and specify that it's not 275, that it is in fact 355. So I've got the grades, I've got the sections, I've got all the different standard sections. Somebody's built a group called Fred. I've got flat bars, round bars, European sections, angles, channels, T's, split sections. And we can also go in and do things like ask for a built-up section. So I now can give myself a 450. Let's make this quite big, make it 900 deep. Let's just zoom in here and see this section. And then I can take this and say I want to put in some holes. And I can ask it to pop in some holes on this 900 deep section. And if I come back and regenerate, it should have the holes in there by default, and I could say I wanted to fill in the hole at 2 meters, and there, that one's filled in. So I can do cellular beams, I can do plate girders, as you will see in the front here. I can also do concrete sections, those are concrete beams. All very, very straightforward. We also have timber. We can do nondescript sections as well. You can also create your own libraries of steel sections. We have libraries of the American sections in a separate database, and also the South African, and I think it's the Russian databases. I would need to check on that one, available for you to use. So changing sections is very, very straightforward. Loads, the loads that we can handle are numerous. So if I went into member loading and I just took this into plan, and one of the reasons I was getting confused, I didn't realize, because I hadn't been looking, that this thing had been already skewed onto an angle. So when I went to rear view, that's why I was only seeing one member. That's very clever, Tommy. So if I just say, right, let's have a wee look at this view, put it in the front view, and let's look at the loading. I can say, right, let's put in 2 loads, and we're going to call them D1 and L1, and I'm going to put them in as 20 and 30 kilonewtons. I can then take those and I can copy them onto those 3 members, and if I ask it to draw them, I can see that those are now coming in, and that's drawing it with magnification due to the load factoring. In a particular case, I've just removed that, come back to the basics. So let's go back to the editing, and now I can say, right, let's take this individual member and we're going to put a point load onto it of 45 at 5 meters, and we'll have another one of 35, and we're going to put that at 2 meters. So we can put point loads and put UDLs. We have all the different load intensities. Just because it's PowerPad doesn't limit what it can actually do. We can apply partial fixity, so we can take a member and make it partially fixed. We can apply compression only and tension only. thermal expansion, so we can do that. We can even, if we wanted to, in a gable, we could put in a gable post and say that it is no axial. So if I went to the front elevation, I could tell it that these don't have any axial, so that in fact the loading would come through from the wind for bending, but this rafter will be allowed to go up and down, so we'd still design the full portal. And obviously you'd do that if you wanted to allow for an extension in the future. Okay, so that's loading, that's section properties. Loading cases. Well, loading cases really comes down to what design code you're going to work with. So design codes, we have the British and South African, and more recently in the last 5 years the European, but with the built-in Euro norm and UK national annex values. So I'm going to work with the UK. You can create your own little annex and add it in if you're working overseas. Just change the 1 or 2 values in the table to do so. It's very, very straightforward. So I'm now said that I'm going to work to Eurocode. So let's go and look at our loading cases. So loading cases, we can add in, and we've already got 16 cases put in here, quite a lot of different cases, and we can see from our diagrams that it's quite complicated in different areas. But what you'd normally do is to come along for each case and set out your load combinations. So you have your leading and your secondary live loads plus your dead load, the 1.25 dead load in this case, as we have chosen, due to the equations in the code and our own preference. And I used to have to go and set all these manually. But in 2015 we produced a fantastic little program to auto-generate loading cases. So what I'm going to do first of all, excuse me 1 second, I think I'm picking up a cold, so I'm getting a wee bit hoarse, but I should survive the afternoon, and I'm going to delete all of those cases. So I'm starting with one loading case, and now I'm going to go into the auto-generate, this fantastic tool that we're going to say for dead, live, live only, dead plus live if we have wind cases applied, and dead plus live plus wind, we want to have all these cases, and we're going to use, if we look at dead plus live, we're going to use the structural 610A and B loading combinations. And if we look at live load only, it's going to be surface. Dev load only is going to be surface. That's going to be structural 610A and B. And we can say we want equivalent horizontal notional forces. And we're going to do them at, we don't need the 90s because it's a, well no, we probably do need the 90s actually, it's a space frame. And put that in, was that a comma? Yes it is now. And we're going to replace all the loading cases, and we're going to use it for the load groups used, and we're going to generate all of our loading combinations, and we're going to say generate. So now we have 22 loading cases. Remember, to the Eurocode, everything has a horizontal equivalent horizontal load on it. So you don't have those separate as you did in the BS days. But we now have all our fancy loading cases set out. And if we look at our combinations, you'll see the 1.2. So if we step back to the very start, you'll see it's 1.2 plus 1.5. And then the 1.3 plus 1.05, and going through all the rules and permutations as per the code. So that is the editing facility. Obviously we have advanced facilities for your pinned bases, fixed bases, spring partially fixed bases, useful for getting your deflections down, settling bases. I can't go through all of these obviously clearly today. So I've already taken half of the time, and I'm just on master frame because it is such a fundamental and powerful program. What I'm going to do is I'm going to come out of this. I'm not going to save anything. I'm going to go back out to the full view. I'm going to analyze it. and I seem to have slipped in some extra members. Yes, I did. I said not to save it, but I must have. So this frame was right up to the 100 member limit. So so the PowerPad 300 would work, but not this version. So if I just open this version with a little cantilever and analyze this for the 100 members, we should find that we can then go in and look at output, graphical. I think I've got no loading in this. No, I have loading on it. Yes, I did have loading. I remember. I did put loading. So obviously you don't look at those with the 3D. We can see all the beams coming through, and we can see in here, if we just reduce the scale and take off the node points, we don't need those. We can see this, the primary beams and then the secondary beams that are supported. The fixity that's coming through in this case, because somebody was playing around, and therefore we're getting a little moment in the columns there. We see the major moment in those, but the minor and the externals, because we aren't taking those to have no axial, they are taking propping action. And if we wanted to check that one out, we can ask it to show me the values and see the propping action of 58 kilonewtons coming through onto those columns and back out again. So we have fantastic reviewing tools. Sorry, no values. And we can look at deflected shapes. Ooh, very scary. And we can look at deflected shape with geometry. Always makes more sense. But let's demagnify this, and we can say, at 1:1, there's not very much movement. Hallelujah, that's great. You know, more reassuring. So let's look at our X displacement, so we can see that under ultimate. But let's just go for surface cases. We can see that we're moving 21 mil horizontally on these in the X, and we just check out the Z as well, and we're moving 35 mil, 45 mil up here at the apex and the Z axis. Axis, very simple, it's moving that way, backward and forward. So because of the way the bracing and everything's working, we're actually probably need stiffer bracing to make this truss not move so much out of plane. Very interesting. So we have all our checks and values here. We can obviously print all of this, and I will show you some printouts later on, rather than taking the time to do those now. So that was the output. Let's go into the design, into our second of all our programs, steel design. Very quickly, we can look at our individual members and look at the portions of those members. We can look at our axial moment restraints, our lateral restraints, in this case 1.8 meters. We can then also look at the Appendix G, where the user has put his stays. So if I go to a more critical member, probably this one here, we can see where we have our axial moment, and then our Appendix G is checking it, and we have already put a stay at 1.8 and 1.8. So we have a few stays along it, and we're seeing the rest is out there. And if I come down to this portion, you'll see that it needs the stays, and we can take the stays out and see it happens. Take all the knee braces, and we can see actually for this, it is actually quite happy to work without any restraint. It's obviously far too big a section for the design. Design wise, obviously, I'm just going through. It's very simple. We can either change a section down and see what happens, and we can say, whoa, that's giving us a failure. Very simple, very clear. Blue screens, red little highlights, something's wrong. But before we do the Appendix G, let's just quickly look at the axial with moment, and we can see that even in this we're getting deflection failures overall. So you know, we would need to move up, and we would move up one at a time until we find one that works at 45 kilogram at 356 deep. What about a deeper, lighter section in the 400s? I could get away with a 39. That's going to save me a pound or two. But naturally we can resort these to sort them by weight order, and then come down to something quite low, say a 25 kilogram, go slowly up until I find the lightest section that's going to work. I've got some failures removed, not all of them. That's now working. Check it in there, and now we would check our stay. So the 39 kilogram 406 works. Looks good to me. But I can also ask it to size it up itself, and now it's found that lightest section, which is the same one, to work. I can do that then on the Appendix G as well, confirm that we do not need the additional stays. Happy days. Out to the end of the point of counterflexure, we can get this to work without having additional stays or knee braces. And we can do it not just on the one member, we can go and do this on all of the visible members. And off it goes very quickly. It's a small frame. 1, 2, 3, 4, 5, 6, 10, all done. So all the members are now sized up according to make them the lightest sections. They're going to work and still not give us any problems with deflections or with anything else. And we obviously have all the different types of design checks. So for example, we can look at this one, and it's a strut and tie, and it's way down to the 76. We also have facilities we could say that we want to have a minimum of 100, and therefore it's going to take me up to the 114s. So I can resize that, and it's going to tell me the 114 works. I can also have maximums, and I can set those per check or globally in the frame. So the design checks are very powerful. One of the nicest things after you do your design checks is to actually not just print it out, but to see clearly how everything is looking. So what we can do is we can scan the frame and say, are there any failures? Have a quick check. 20, 30, 40 members, 50, 60 members done. 14 members are now a wee bit upset due to something that I hadn't looked at in the bracing, the struts and ties of these. I didn't look at those. And I can display that graphically now on the screen. I can display all my unity values. The ones that are in cyan may have a buckling problem. The ones that are in purple aren't checked at all. The ones that are in black, happy days. They are fine. And I can say give me the maximum for each type of section, or only show me any failing members for whatever reason. So it's saying these all as being fine. So those are all tools that you have in your armor for doing your steel design. So that's the steel, the eye sections, the hollow sections, the angles, channels and teeth, all done inside this program. So moving on, I can then reanalyze this quickly, space frame, and go into design of my concrete. So we don't need to cover the concrete separately. It's looking for 2 additional cases because I didn't put them in. And I'm going to design it. I'm going to accept all the defaults. C4 3240 concrete, accept all the defaults. And it's now running through. And I can look at these members here and design those for the reinforcement. Obviously, it's not necessarily the best example, but we are getting our lovely reinforcement here, 416s down to 312s, well, maybe go up to 412s at the mid-spans for our continuity links and reinforcement. But we do only have 3 links, so possibly, yeah, it was right. I can say, no, I want to work in this beam particularly. With only having a maximum of 3 bars. So let's keep ourselves down to a 3-bar arrangement. Say OK and auto design that, and I now come out with 320s, 312s, 316s. Obviously we need to look at, in this case, the different section sizes can be problematic. And go through with that, and we look at our inner beam runs. We can see again it hasn't been redone for that. Resize that and resize that. So it's had to disobey that rule because it just wasn't happy. The reinforcement is a lot heavier. It's saying no, I can't do it. So at the minute that's what you're going to have to use. So it's very smart and holds your hands. It'll do what you tell it where it can, but in other places it'll say no, I need bigger, and it will actually give you a solution. You're able at any time to change all this, very straightforward. You can take bars and you can move them about. You can reduce their size, and as soon as you start to get failures, it'll highlight those for you. It's doing all the Eurocode elastic drag. It's just so simple and powerful, and we can take this straight out to AutoCAD. So if you wanted to take a detail, there's a nice pad foundation designed for you, and I always like to see a pad being designed because it's pretty straightforward. We have uplifts, so therefore we got top and bottom steel in this pad due to the lack of weight in certain areas, in certain loading cases. We also have, one of the nice things is, in the steel design you can go and change your section size and see what happens. In the concrete design, that's still the same. So you can come in and say, well, actually, what would happen if I went for a 600 deep beam? It's reassessed it, and if you resize, it'll say, well, actually, you would get away with that reinforcement, not the 25s, but the 20s now, with that deeper section, and that's a choice you can make yourself. All of this can be exported into DXF, but what I would like to do just very quickly to finish that off is a concrete, simple, plane frame. Analyze that as a plane frame. Everything's happy. Design as the concrete you saw before. That's okay. And you can see it's a lot more intelligent because this one's been more thought out. In fact, in the concrete, we just need to make a few adjustments. We can have multiple beams joined together. We can have steps. We can have T-sections. So if I was to quickly export that, okay, very quickly export. We would get into my AutoCAD. I have 14, 15 and 16, but just the 14 is the one bound onto the program at the moment, and I can see all of my lovely details here exported out, ready for issuing. So that was very quick. So that's the concrete. So that was the concrete little whistle stop tour. Save this, yeah, why not? And exit from master frame. So I want to now go quickly into the portals. We don't need to go into as much detail because we've already seen a lot of it. So let's just take a simple 2-bay portal frame into the editor. We will work to the Eurocode. Yes, I'm happy. And we will use A and B. Oh, get a little message. Thank you very much. And we're in the simplified. Yeah, that's okay. Interface. We're putting in our basic loading. We've got our spans, 30 and 24 meters, or columns. We could put in props. We could put in a lean-to, canopies, crane beams, and mezzanine floors. But I'm not going to do any of that. And I'm just going to quickly go through and say, right, let's go analyze, do a plastic analysis. Yeah, plane frame and into design. Steel design, no different to before. Well, slightly different in the way it does auto sizing and things like that. It's a lot more powerful. If I move down into looking at the member checks, this stage we're not talking about for our Appendix G's portions, but we're talking about where the restraints are, and I can say, if I restrain it there, would it work? If I restrain it there, I wouldn't need one there, and then everything else works. So that's just quickly assessed that rafter and seen that that one just needs that one purlin restraint, and it's a more efficient way of doing it than in the of the program. We do always have all the additional information, such as elastic critical load factors, whether or not we need to do P delta. There's no P delta, but that's okay. We didn't need to do it. No second order analysis required. The notional loading is all fine. So other than that, its interface is very similar to the previous steel design, and it's a very simple program to use. This is probably a good time to introduce the connections, which we can do in the frames as well as in the portals connection design. Somebody has already done some connections here, which is quite handy for me. I'm going to come in and create a new connection. Again, if you want a full review of the connections, have a wee look at the connection video. I'm going to do a beam splice, and I'm going to do a splice on this member, and it's going to be at 6 meters along the member. Say OK. There's my splice, and lo and behold, it actually does work. And I would just check that that works for all cases. All the loading cases don't give it a problem. But if I wanted to, I could come along and say I want the top plate to have 4 bolts. And if I wanted the bottom plate to have 4 bolts, I can do so. If I wanted to decide in here that I wanted actually to have nothing in here, just put that at 0. Oops. But then I can go to the interior, and I will have a 10mm thick interior bolt. And I can even turn around and say that I want the bolts to be countersunk. So they're now countersunk, and the design checks all perform to that. So you have all of your standard connection checks, your eaves, your apex, your base plates, your beam splices. In portals, in your multi-story frames, we also in the ordinary frames have the simple connections. So the connections is a great addition to your armory. So just coming out of the portals, so that's the portals covered. I'm now going to go to look at the standalone programs. So what do we have? Our designer suite. We have got this fantastic composite beam program. No slim floor, that's part of the big program. So let's take a new beam. Very simply, call it Tommy. And I'm going to go for a secondary beam that's 9.1 meters long. It's going to have 6 live, 1 partitions, 0.5 surfaces. The beams to either side are going to be at 3.2, and I'm going to make it an edge beam, and I just do that by making that one 0. Okay, you could have argued that it should have gone the other way around. It won't actually matter, it just looks better on the screen. So on prop composite secondary edge beam. Does it work? Well, the answer is no. And we can see from our results that we have problems with our transverse reinforcement. So let's get back up and either choose a section or mesh. I'm just going to work with the basic and let it try and solve it, and it's come up with this section, a 254 146 40 UB43, so 43 kilogram UB, but in the 254 depths. If I went for shallowest, I could then ask it again, and it's come up with a 406 that's only 39 kilogram, which to me actually looks better. We didn't need to go to that extent. So we've got our primary beams, we've got our secondary beams in this program, and it's very, very, very straightforward to use. That's how quick it is to look at the composite. Now the next program in here is the masonry. Again, straightforward. Take a new file. We have walls, and we can say, right, we've got a wall that is 4.5 meters wide. It is 3.2 meters high. Its effective heights and widths are normal, no modification. We'll go for a standard brick and block, and we will actually turn around and say it's fixed in the base and it's fixed on one side. And if you wanted to, you could say that it is in fact free at the top. So you just click on these, that's pinned, that's fixed. That's partially fixed, which is a wee bit of an academic thing, can be useful, but in my case I want it just to be pinned. So pinned, fixed, fixed. So that's the wall, inner leaf, concrete blocks, group 2, unit strength 10.4s. No additional loads from above. So it's not a multi-story carrying additional loads. That is the inner leaf. Well, let's put some load onto it from the inner for the inner leaf. Concentric from above is going to be, say, 10 kilonewtons and 5. Eccentric from this from the top of this level, from a floor or something, will be again the same load, 10 and 5 at the standard 20 mil eccentricity. Outer leaf, we're going to go for 7 to 12% blocks, group 1. And now for the important thing, the outer leaf, we're going to have no additional load. Well, you could argue that you're going to have maybe a 10 kilonewton load from the upper level blocks anyway. And then the lateral loading. And this is where I put in my wind loading, and I'm going to say I can have a wind load of 1.2 kilonewtons per meter square. Not central London, but somewhere up in Scotland or over with us in Northern Ireland here. And we will then see that it still works. It still works, and it's getting pretty close in its moment capacity 0.9. If I said 1.5, because it's in the Orkneys or somewhere more severe than that, we can then quickly say, well, let's strengthen our block, see what happens. It helps a wee bit. After a certain point, there's no additional enhancement to strength. So we'll leave it at the 10.4s. What we'll need to do is add in a thicker leaf or request that this is fixed. So quick set, fix it on that side, and it works. So if we could get fixity, it would work. We would be happy. If we could get 30% of fixity, it wouldn't work. So other solution is to think about increasing the wall thickness. So I actually just do that here and say at a 140 thick masonry inner leaf, it would now work for that quite heavy loading. Obviously, because we're in PowerPad, we do not have openings accessible to us. In my license I do, but in the PowerPad version you do not have openings or bed reinforcement. So that's masonry walls. We can also ask it if we wanted to do a piered wall. We can do a piered wall that is in fact freestanding. So if we had a piered freestanding wall that was a single leaf, we would be in slight trouble. We would need to make it a lot thicker to make it work with that wind pressure. And we could just play around with the parameters to make that work. But time is of the essence, so let's keep going. We'll just save that, yes. Okay, retaining walls. Another powerful program that's in the MasterSeries suite and in the PowerPad. We'll take my retaining wall, and we'll see that in this case it's a simple retaining wall with a wind pressure. We upstand, and we do have problems with sliding and bearing. So sliding and bearing mean that we really need additional weight on the wall. So we would have to either extend this to 1.8, 1.9. There we go, 2.3 meters long. We've now got enough weight on the back of this to make it work. We could also maybe think about going to the soil data and for the base put in a cohesion value of at least say 10 kilonewtons and see if that solves it. That solved our sliding but not our bearing pressure. That's never going to help bearing pressure. So to reduce the bearing pressure we need to make the whole base longer or reassess what the actual bearing pressure is. So back soil base, we see the bearing pressure is set at 100. Okay, it's going to be a sandy soil. Let's go for 150. Problem solved by putting in the correct values. We can also put in a base prop if we knew it was going to be fixed up against something else, like an additional slab, or it was a basement in a building, we can do that. So very, very straightforward, very easy to do. If we are looking at masonry, then we can say let's have a masonry wall, and obviously that would not work. We would need to do that, and obviously the reinforcement would no longer exist. Because we're in the PowerPad version, the reinforcement would no longer exist on the wall, because we don't do reinforced masonry in the PowerPad version, just the full version. And you'll see now that we would need a colossal size of wall to make that work. If we wanted to, we could say let's go for a stepped wall and take that right out. We're still getting quite big on the wall at our dimensions, so it's not something I would be suggesting that you would consider very, very often. So very simple, very straightforward, your retaining walls. So we've covered nearly all of the programs in our designer suite. We have the simple beam designers for steel, concrete and timber, and this is where I'll just a wee quick glimpse into the timber for us. So you didn't think I was going to cover them all in an hour, since I've been playing around with Master Frame for so long, but it's very, very simple and straightforward to do. And I'm just going to take this beam. It's a timber beam, and it's showing us the loading on this frame. 2 spans, great. A 2 meter, well, let's make this worse by making it a 2.5 meter span, or better in fact. And we can see now that our deflections are going to be between 5 and 1.5 mil up or down, depending on what's loading on this, because obviously we want to use alternate loading. And I'm probably in the BS. Yeah, BS is unfactored. Sorry, Tommy. Design code. Let's use the Euro code, and that actually does it all for them. So actually you don't have to edit that, it does it all for you. And we now get, with the factored, non-factored, we get all of our values a bit bigger. So let's look at the serviceability, and we'll see that we're nothing here. So I would suggest that we should consider additional serviceability on the alternate loading cases, because that's not necessarily the most critical one. And we can see are more critical in our combinations. So that's the analysis, and it's very, very straightforward. It's very easy to use, and we've just told it it's a cantilever, or we could say it's continuous. So it's just a 2-span continuous beam, or in this case a cantilever, and we get all the movement we expect. Point loads, we'll just put another point load onto it on span 1, and we'll put a point load that's a wall, say of 12 kilonewtons, and we'll put that at 1 meter out. So we've got another point load, which has just made the whole scenario worse, and we're getting an upward movement of 13 millimeters due to that point load, because cantilevers don't always go down in real life, they can go up because of what is resisting them. And as you can see, partial UDLs as well and everything. So into design, just to have a quick look at the timber. And there we go, we can see that this member is bearing is 2.4, but the others are 1.5. So let's have a wee quick look at the materials, and we will go for C24, and we're getting a wee bit better, and we just need to look at what our bearing length is to sort out that. But before we look at bearing, let's sort out the rest of the dimensions. And it is pretty big beam, it's pretty big loading, so I'm going to go for a 100 by 250, and that's getting me close. These are unrealistic sections. Possibly it would be glue lammed, and possibly it would be, because it's going to be a main beam rather than a joist in this scenario. And I'm going to go for 100, and by say 300 would probably cover it. And now we've got everything we want to work. Oh, sorry, no, Tommy, not 3,000, 300. That's better. I was getting scared there for a minute. And we can see the only thing that's not working for that is the bearing. And there is somewhere in here, if I can remember where it is, that I set the bearing width of the section. and so members, slenderness, distance to bearing. So if I actually said no, we're going to have a 200 bearing, that's getting me. So I'm still having a problem with this bearing. So I maybe need to go for a bigger section just to get the bearing to work properly. Sorry, I apologize, I'm reading the wrong value. Doing too much talking, not enough reading. That's the bearing length, and the bearing length is going to give me, say, 125. It's going to work. Would 100 work? I doubt it. That's too. So if we can guarantee we can get 125 of bearing, then we are happy. That glulam fancy section of beam will work in the structure. Naturally, everything is editable. Your buckling, your axle with moment values, materials, whether it is internal, and with a cantilever it may be external, fully exposed, at which point we need to up the ante again and make it a deeper section to make this work. So that is it in essence. Steel, concrete, timber, frames, portal frames, simple beams, all part of this PowerPad family. Retaining walls, masonry walls, composite beams, all part of that. I'm just going to save that for myself and just come out of that. Now, I did say I would look at some output, and just to be pretty quick and brief, I'll not do it in here, I'll do it in the main program. And if I go to products, light, and you can do the same here yourself, go into the PowerPad and look at the output. The brochure is well out of date, ignore that, but the output, it'll give you a good idea of what we can do. And we can do our frames. There's our little frames, sort of similar to what we were doing there now, with all our output, our data file, our numerical results, looks good, some nice pretty diagrams, envelopes of results, deflected shapes with some values. And what I'm going to do is just going to zoom in a wee bit more and see that you actually can look at and see what your deflected shape is in those axes. And we're looking at the X and Y displacements in this case, so horizontal and vertical. And we're looking here at the shearing forces on a floor, which would give you your beam connection design. If you're giving those over to a fabricator, you can say, here you are, here's your shear at the ends of members. That's your axial loads. Just because he could do it, he did it. Your design checks that we looked at, the summary of them, and we're seeing the ones that we want to print out in detail. All of them are passing. Nope, here you have one that's failing. So we've just shown you a failing one to show you that it would show up highlighted separately. Our detailed checks that we saw earlier, and a simple column construction check. Our connection, there we come through. I believe this is still to the BS, the set of output. Yeah, it is, but the output's the same for the Eurocode, just different numbers. Simple connections, we didn't look at those, but they're all part of this PowerPad system. So I mean, this brochure, this document is probably a great brochure. There's your concrete beams, nicely detailed. In this case, quite a simple beam. A nice column design, biaxial short braced, and giving you all the calcs. A nice pad foundation that's coming into a circular column, so it's giving you all the hoops and everything for that circular column. What have we got now? Our composite that we did, our masonry walls, and our freestanding wall with 0.75 wind loading and piers. Our little retaining wall, which in this case is tapered. There's a stepped retaining wall. As you can see, the sizes can get quite big. That's only 1500 high, but as you know, you are talking about a 3:1 ratio normally for those sorts of retaining walls. Your timber members that we did. So all of that is part of the PowerPad system. So, ladies and gentlemen, I'd like to thank you all for coming along. I'm going to just take you through some little extra areas that will be of help to you, and to say that obviously If you're not a user of our software, you're more than welcome to come along and request a free trial. So if I come back to the PowerPad, request a free trial, pop in your details, and we will get you a free trial 30 days on your PC of the PowerPad system or any other of our software that you want to try. We also have, and this is useful, when you do get your free trial, you will get a user login credentials to go into our user area for 30 days. I'm just going to log in here, and we will see that we have obviously got some downloads, but more importantly, we've got a whole stack of videos on doing things. So there's a brilliant pair of videos here that we did over the summer on MasterFrame, all the editing tools of how to use it, all the tricks, all the shortcuts. I'll just turn off the noise. I don't want to see that. And we'll see, as the guy's talking, he's going in and he's creating members, and he's working through the frame here for you with the snap grids, and it's very straightforward. Now, as well as that, you have the manuals, you have your technical notes. If I'm using the program, at any stage, if I went into a particular program, say retaining walls, and I was inside here, everything is intelligent. So the help is intelligent. I can look at retaining walls in here, and it's just gone to a different page, and I can now see, pulled off my computer, the brochure, the manual for the retaining walls, and everything all automatically available for you. So coming back to the website, so we've got our manuals and documentation. Also, we have technical notes. These are little things that need to be clarified for some people. Somebody actually asked me today, how do I do shear wall modeling? Well, actually in PowerPad you can't do it, but if he's on the line now, that tells you how to do shear walls. You would need to use the full MasterFrame to do the shear wall modeling with the model manager to help you. So you have your beam designers, how you set up your support conditions and super members, how to use the calculation wizard, and the masonry, how the reduced fixity works in openings, all this. What are these effective lengths and heights? And it takes you to a little guide on the code and what this is all about. So we have all these technical notes. Now we have one more port of call, and that is that we do have, what's this, a YouTube channel that you're able to come along and watch videos from outside the system. Some of our better videos are all put into the YouTube channel for you to see and to review, and you can watch those, and all of those are inside the system as well. So PowerPad, somebody's been asking how much it is. Well, obviously it depends on your currency and things like that, but the basic PowerPad is coming in around 2 to 2.5K for the PowerPad Plus. It's fully upgradable. So for example, if you wanted the PowerPad but you wanted to have the retaining walls, where is it, masonry, retaining walls without the restrictions, you could add that in for a small upgrade. That is the full price of the retaining wall, so the retaining wall component is in that. So that's all available to you as well. I would like to thank you all for coming along today, and remind you, you want a trial, you can just email in from our website and get a trial. If you need to speak to me, my name's Tommy White, and I'm usually here. You can either phone me or give me an email. My email address is tommy@masterseries.co.uk or .co.com. It does not matter. I am usually here. So in essence, to summarize, this is the whole structure of PowerPad.